I'm Mike Tipping. I'm a researcher at Microsoft Research in Cambridge. I work in an area that we like to call machine learning, I guess. We're interested in kind of learning algorithms, mathematics, probability and statistics. And at the moment, we're trying to make the most of using learning algorithms to improve artificial intelligence systems in video games. So we're particularly keen on getting these novel kind of learning features into forthcoming Microsoft Xbox games.
Okay. And who are you?
My name is Ralph Fabric. I'm also a researcher of the Machine Learning Perception Group here at Cambridge. As Mike has already said, we're working primarily on probabilistic methods of learning, sometimes also called Bayesian learning, and I very much do the same job than Mike, trying to apply that technology to computer games in modeling opponents as well as other jobs that arise when you play games.
Okay. So what exactly does that mean? Applying artificial intelligence into a game. As a game player, what would I see? What would the end results of that be?
Well, as a game player, you typically interact with a number of what one might call agents in the world or non-player characters. So these can either be, I think most prominently, these are your opponents, whether, for example, it's a driving game, they are the drivers of the opposition cars, the cars you're racing against. If it's a shooter, first-person shooter, then these are traditionally the bug-eyed monsters that attack you down every corridor. So these are your opponents, and they're all controlled by some kind of artificial intelligence algorithm that simply determines their actions and how they behave. But as well as your opponents, you can have, for example, teammates. So it could be a football game, let's say, a soccer game. Where
I was just going to ask whether you meant real football or American football.
Yes, of course I meant real football because I'm English. But yes, they could be your teammates in any kind of sports game. And again, you want those to behave in a kind of intelligent manner. So all these different kind of agents in games, whether they be your opponents or your teammates, you expect them to behave in a manner that befits what they are. So if they're humans driving a car, you expect them to drive in a way that you consider consistent with other humans. And the same way, if they're your friend who is a medieval elf with a bow, you expect him to fire his bow just like all your medieval elf friends would in the real world. So we've got a lot of creatures and agents, characters, then we all want them to behave in some kind of intelligent way for the role they're doing.
And do you have many medieval elf bowman friends?
Not in Cambridge, no.
So one important aspect of the bringing machine learning into that equation is that these, usually with most games, the behavior, as Mike termed it, the policy they are following, the behavior they're carrying out, is scripted, is sort of fixed during development a priori. And so the behavior, as it were, doesn't change when you play the game, when you ship the game. It has still rules that depend on what you do, they're sort of dependent on what you do. But the rules themselves do not change. And learning brings in the idea of learning brings the possibility that the rule set changes so as to, be optimally evil against you if they're your opponents, or optimally helpful if they're your teammates.
So can you give me an example of how this might work in a real life game?
Well, a classic example will be the game we're actually working on now. So we've been developing the AI system that controls the drivers in a forthcoming Microsoft Xbox game called Forza Motorsport. So there's actually us two, and we have another developer here, Mark, who's not in with us today. And we're also working in conjunction with an AI developer in Redmond, a guy named Barry Brummett. The whole lot of us, we're trying to imbue the opponent cars in this driving game with far more human features. So one way we could do this is we could come up with some really clever algorithms for programming, so that, for example, a list of rules that control how a car drives around the track, what lines it takes through different corners, and what speeds it takes in that, for example. So what our kind of learning spin on that Ralph is getting at is that why not make these behaviors adaptive, and in particular, why not make the line and speed a car takes around the track, why not make it learn, if you like, from the way you or I might drive. So in Forza, for example, we have this feature that was announced at E3 called the drivatar system. And if you buy the game, you'll be able to sit down at it, you'll be able to take some lessons where you'll drive around a track, and the learning algorithm that we've built into it will monitor the lines and speeds that you follow around the track, and it will use that information to build not just a recording of what you did, but it will actually build what we would call a mathematical model. There is some sort of set of parameters, some a collection of numbers, if you like. It's talking very basic terms, which represents the way that you drive. And the idea is then we can take you from, say, driving a Mini around an oval to putting you into, say, let's say a Porsche Carrera driving around a much more complex circuit, let's say Laguna Seca in California. And we can have that car drive particular lines and speeds around the track that are consistent with the way that you drove in a totally different car in a totally different place. So that's the kind of way we're trying to get the learning to change the way that the game works in a way that gives you a very positive experience for the player. So
it's kind of a ghost, like an intelligent ghost. A ghost drive is usually an exact copy of yours. So it will only work on exactly the same track with exactly the same behavior of all the other cars. Because it's just a replay. And the way it makes us intelligent is extracting what sort of lines to take and what sort of chicanes, what sort of speeds to take and what sort of chicanes. And then, of course, being able to apply it to slightly varying environmental conditions, like the track changes slightly, as Mike said, going to Laguna Seca from a country track or so, or going from one car that has one particular physics, like the Mini, to another car that has slightly different physics, such as the Porsche. So it's trying to find your way of driving, learning this in a mathematical model, as Mike said, and it's therefore a intelligent ghost, if you wish.
Okay.
A copy of yourself. That's what I
So
call
does
it.
this also map into your into the way that the opponents drive on the course as well, or the way that opponents would play against you in any other game? So driving is one example. If you're a complete novice driver, does that mean that all the other cars you're driving against have got novice behavior, and as your driving skill improves, their driving skill improves as well?
that is one possibility that's realizable by the system, yes. So you can, for example, one thing you can do is you can race against yourself, which is sort of like the ultimately personalized opponent. It's the opponent that's exactly as good as you. So you would hope that if you continually did that, you would be able to improve by continually competing against someone who's just as good as you are.
So even if you lose, you win. Is that right?
Yeah, that's one way of looking at it.
Win-win situation, yeah.
Yeah.
So we can sort of kind of use this learning technology in a variety of ways, and I can't unfortunately demonstrate it at the moment because we haven't settled in concrete exactly how this is going to be exploited.
Right.
This technology is in there, and it will be deployed in several scenarios when the game comes out.
So one important, because you were asking what has the gamer, what's the gamer gaining in having that feature in the game?
Mm-hmm.
One thing is that the lifespan of the gamer will possibly extend because he's not stuck with the sort of opponents. If he doesn't play online or with other friends, he's stuck with the opponents that are in the game.
Right.
But this can be downloadable and tradable content. This can also be you bring your friends around your house, have a little session on a Saturday afternoon. Now they're gone next day, you still want to play. You can take their
driving skills.
their avatars,
Right.
avatars as we call them, as your opponents, and continue to have fun without them.
Right.
Of course, the longer they play with you, the better their model is. So it doesn't come for free. It's not
Right.
that they only have to play for 10 minutes and there you have an exact copy of them.
Uh-huh.
So if I, for example, play with Ralph multiplayer, I typically would beat him in every race. And if I really get off on that simple kind of victory, I can take his driver car home with me and I can continue to beat him at home. So he might dispute some of the technical details.
But I could do the same thing, by the way.
Right.
Ralph could try and improve himself by
Yeah.
racing against me in the privacy of his own lane.
Right. Fantastic. Okay, so is there anything else you want to tell us about the work you're doing?
I guess to give some general background on what we're actually trying to do, so as not to mislead people into thinking we're playing all day purely in racing games.
Yeah.
So we're trying to, in general, what we're trying to do is we're trying to improve the AI in games out there. So anyone who's played video games will know if they've seen reviews, for example, or they play them themselves. A lot of games have accusations leveled against them that the AI is dumb or weak or frustrating. So it's one of our aims in this group is to try, and at least in Microsoft games anyway, is to try and improve the AI systems, which is what we're trying to do with Forza, to get rid of these frustrations and these annoyances, to try and make them more realistic and more challenging in a fair way. So we're trying to do this a kind of, I would say, across the board, but we only have a finite amount of time. But we're trying to work on a number of titles within Microsoft and titles we're also publishing to try and sort of improve the level of the AI everywhere
Right.
in Xbox games that Microsoft is involved with. At the same time, it's a sort of exceedingly challenging in terms of we only have so many hours and we're already spending ridiculous hours on our current projects. And so we're also looking at ways we can generalize this by sort of writing libraries of routines and AI code that is more sophisticated than what's out there already, but is sort of equally usable, and we can kind of distribute this in a very efficient way.
So does this also map through to not only Xbox games, but also the Microsoft desktop game titles as well?
Yes, such as they are, definitely. We certainly don't see ourselves as Xbox exclusive, and in fact, there are probably advantages for our kind of learning to have the facilities of the PC, the sort of faster processors and the disk drives, for example. That we have a lot more sort of facilities at our disposal, which actually makes our kind of algorithms easier to implement.
Right. Okay. Anything you want to wrap up with?
Oh, Ralph, I think. Put you on the spot here.
Yeah, I mean, following on what Mike said, there's one, this one part of our work is working directly on Microsoft products such as Forza, and future products we can't talk about today. But another aspect is that we also try to advance state of the art in the academic side, and that which is pretty young anyway.
Mm-hmm.
There's not many groups worldwide that work on gaming AI. And so for the last year or so, we had some sort of more research-oriented experiment running where we tried to bring a learning technique that doesn't need user input as such. So in this sort of copying feature we described, needs the user to play and then copies the user. So we've worked on an algorithm for the last year or so within Microsoft title, so within real game code, that tries to improve itself by self-play. So the computer plays against itself and tries to figure out, again, builds a mathematical model that knows what is the optimal action, what is the action that maximizes my gain, which could be simply keep staying alive, or which could be the lap time in a driving game, automatically. So it's sort of, initially it's just randomly trying out steering actions or punches and kicks, if it's, depending on the game genre, and over time then it sort of learns in that situation and was always most successful with that sort of action.
Mm-hmm.
And there are currently plans that we want to, because you asked, this is only Xbox limited, that we want to collaborate with people from MSN Games to bring this into one of their mini, they have mini games where, because our findings were that the level of excellence is not world player, but it's sufficiently good to be like, 50% of the people, and MSN Games is has a need for that sort of technology to have an AI that is reasonably well against the majority of people, but doesn't need to play at world strength.
Right.
So you're talking about things like backgammon and...
Backgammon is the prime example here, because backgammon, it's even been shown in the academic world that this sort of technology works pretty well with that sort of game. So that's where we, exploring as well possibilities to apply these adaptive technologies in games, just not only Xbox market.
Yeah. So when you do get your own medieval elven friends, come to us and we'll program them for you.
Fantastic.